So suppose we do have the globe in the geography class. Then we have a butter of electrons and spread it on a surface, right? Then we spin it, and then it will be moving charges on the trajectory. Moving charges means electric current, and electric current creates magnetic field, right? So the idea behind spin that I even probably should switch the recording off because it is not correct. It is only educational trick. But if you say it in the respected circles, people will not like it. But suppose electron rotates around itself and creates magnetic field, and it can rotate one way or other way, right? And if the thing has its own magnetic field, it can be flipped by external magnet. Make sense? So basically that's it. But I'm going to speak for like hour and a half today and on Monday, why spin is cool and why it is always included into quantum theory. There are textbooks, and I know that Wyatt is looking for educational career. So there are textbooks who present physical chemistry and quantum theory in the different logical arrangement. So we started from principles and then went by going from simpler to more complex models like free space, boxes, oscillator, and then other things. In all these systems, we had either infinite number of points on the grid line or infinite amount of angles at which diatomic molecule can rotate, right? Or infinite points inside the box. And therefore, because of this reason, the solution of time independent Schrödinger equation has infinite number. There are infinite number of solutions for time independent Schrödinger equation, correct? This is okay. You are already experts and masters in this subject. But if we would start it over, just getting through principles of quantum theory, one could start from the spin for the following reason. The eigenstates of spin, either energy eigenstates or angular momentum eigenstates, there are only two eigenstates. So it is simplest possible mathematical concept. If we have zero knowledge about natural science, but infinite knowledge about math, and we want just to apply our math skills to natural science, starting from simple would be to look at spin. If we forget about Schrödinger and accept Heisenberg, who was trying to formulate everything in form of matrices, then we are also need to follow spin as a simple system, because matrix for two eigenstates will be 2 by 2. So everything can be done, well, not everything, but a very large number of predictions for realistic properties can be done by pen and paper, just playing with 2 by 2 matrices. So, okay. What else? What is magnetic resonance tomography? Did you hear about it? It's good. It means you're healthy people, and your relatives are also healthy people. Joe, Joshua, and Vola, I'm confident that you're also very healthy, but did you hear, just as a general education, what is magnetic resonance tomography?
No.
No? Okay, good for you. Joshua, you can type or answer. Okay, no answer. Joe? No, okay, wow. Then I feel really lucky. I will be the first one who will tell about this. Oh, Alison is here. Alison, you have some connection to like pharmacy and medicine. Maybe you can teach us briefly what is magnetic resonance tomography.
No, I don't know much about that.
But did you hear it before? At least what it is used for?
No, I didn't.
Okay, that's fine. I thought it is something from everyday activities that I was feeling, how to say, hesitant to tell about things, but okay, you'll hear something new then. So the quiz that we did last time, I briefly cover. So I was also trying to do it, and it is leftovers from previous thing. There is at least one person in the class, not well, I'm giving less uncertainty, but this person is online now, who did this operation and got numbers about in between integers. And the whole idea, I'm not telling that this micro lab was done wrongly, but the whole idea of this Balmer person, scientist, was that to connect natural effects with integer numbers. So if one is getting something non-integer, he was trying to assume that it is just an error and it should be literally 3, literally 4, literally 5. And then making progressions 3, 4, 5, 6, 7, 8. And then plugging in integer numbers into this equation. And then one gets the answer that corresponds to UV spectrophotometry really, really well. Make sense? And we will never return to this equation back, except maybe Joe will mention it. But if you kind of wasting time on old subject, but the key for all spectroscopy of hydrogen, phenomenological spectroscopy without knowledge of quantum theory, is in this equation: 1 over lambda equals a constant times 1 over n squared minus 1 over m squared, where m and n are numbers of eigenstates, and this is called Redwork equation. If we plug in one number equals 2, then m squares converts into 4, and then we get this equation, right, for the lambda. Here's just a little derivation, but the quantum theory was born as an attempt to provide background philosophy for this equation. So this equation was just phenomenologically guessed, was both Balmer formula that we practiced on this micro lab and Redwork formula, which is here, and his name is in the letter R. But it was only phenomenological guess, educated guess. But quantum theory provided the foundations that energies of hydrogen atom follow the 1 over principal quantum number squared. Make sense? Okay, so done with hydrogen. In some sense, if the class would take at least 5 months instead of 4, I would try to go over the same concepts as we applied for harmonic oscillator and to literally apply them to spin. You will see only traces of it. It will be like fast forward remote instead of it, but there are connections between each little piece in harmonic oscillator and description of spin, just bringing up this little analogy. So as I understand, you haven't seen these figures, or you did? How would you characterize it? What is it? Huh? So you know what is MRI? And you told no? I would like to ask you to explain. Maybe you can do it better. So you know MRI, but you don't know magnetic resonance tomography. You know the abbreviation. What is it?
Magnetic resonance imaging, MRI.
Okay. And what is it? What does it do?
It doesn't it like take layers like throughout whatever it's scanning, and then it'll come back as like an image of different layers.
Okay. Okay. Yeah. Anything else? Principles how it works? Does patient needs to drink any contrast or get IV? I'm
not sure.
No.
You don't know, or you are sure that
They don't have to.
they don't have? Okay. There are strong magnet cooled down with most expensive equipment with liquid helium, and things are moving around to navigate and concentrate, focus magnetic field and catch its response on different layers, right? And the old name for this technique is nuclear magnetic resonance tomography. Now it is MRI. There were several accidents on nuclear facilities, and patients were fearing the word nuclear. But the word nuclear deals not with like nuclear bomb or nuclear contamination, but proton is a nucleus of hydrogen atom, or like if one removes all electrons from any element, it will be a nucleus, right? And electrons have spin and nucleus also have spin. The math and background for spins, either it is electron spin or nuclear spin, are the same. But this medical equipment is based on spins of nuclei. So it takes specific range. So this is a wrong and non-necessary figure that we also shouldn't look at, and we shouldn't discuss in public. So it is an analogy that will be beaten by today's lecture. But it's also just a little ramping stage. So if you have a compass or without Earth, compass in a free space without magnetic field, it can rotate freely, right? If we have three-dimensional compass, like magnet that can rotate freely in space, it can take any orientation, and if you rotate it, it will keep rotating as we set it up. If one applies magnetic field, if the kinetic energy is zero or it's damped, it will just orient along the field. If you already made it rotating, then it will just change its pattern of rotation, and it will be still rotating, but in the plane perpendicular to magnetic field, as you see here. And these rotations are made as an analogy to quantum states of the spin. So I'm very against this figure. I just picked it from Wikipedia as an example of what not to do. This figure is better, and it is something what is expected from primarily my CSI and secondarily from Joe. For Joshua, it is a background information. The project that Joshua is doing is based on this effect. So if one has coils with a current going one way and opposite way and places them in a magnetic field, they have different energies, right? If it is forbidden to change their orientation. So the energy of forward going coil will have one sign, backwards another one. And the energies of these coils will increase with strength of magnetic field. This is a background for NMR, one always has strong magnet, and then which doesn't change over time, constant magnet. And second, radio frequency, very low intensity magnetic field that changes over time. But this splitting of magnetic levels is a background of things. For my SSI and for Joe, there is an experimental observation. I was trying to see if one can purchase something or just borrow and make a demonstration class, but it's too expensive and too massive. But basic idea is the name of the thing is so-called Zeeman effect. Ze means sea, man is man, so it's German like seaman, family name. If one takes gas discharge tubes that we practiced last time and places them in a very strong magnetic field, like really strong, spectral lines were, well, our spectrometer was very poor resolution. You will not see this effect, but if you have fine spectrometer that shows very thin lines, after applying strong magnetic field, they will start splitting. And the reason for the splitting is because first electron has its own spin, and depending on the energy, depending on the magnetic field, the energy of spin electrons that rotate down and up change, and transition energies will show splitting. And this effect is observable in the lab, a little bit better equipped than class demonstration. Another thing is if one takes, and my SSI and Joe have an opportunity to vary intensity of magnetic field and observe this effect on the quantum simulation. The splitting may originate either from own spin of electron or from orbital motion of electron forward and backwards, which also creates magnetic dipole and interacts with magnetic field. Make sense? So we didn't start the lecture. It's only an overview what would be great to go through. So if we want to discuss concept of spin on the mathematical language, if you want to follow the path of predicting future and interpreting experiments, one needs to solve either Schrödinger or Heisenberg equations, right? And one needs to formulate operators. Typically, we start from total energy operator, Hamiltonian. And about a week ago, we learned that one can also find eigenstates of the angular momentum operator or annihilation operator, right? So before going forward, we need to get a language. We need to translate concepts about spin, about quantum states, onto math terminology for operators or matrices. And I will be very happy if by the end of today's lecture, we will arrive to the slide, which is summary of most basic operators for spin system, and operators and basis functions shown here have some connection to creation and annihilation operator, if you see here, right? So plus and minus, it goes up, down, down, up. And same as creation and annihilation operator, they are conjugated to each other and they can be converted in something that by mathematical properties looks like position and momentum. I even do not ask you if you accept or reject, because it's new concepts. It's only for information. Here is the two equations. Here are two equations which you would hear if it would be purely experimental aspect of physical chemistry. So if we skip details of the math and just look on the connection between concept of spin and objective realistic measurements, we would need to look on this equation. You can also see it in your inorganic textbook. So if did you took inorganic, you are looking forward to take it next fall, right? So I promise this equation will be there. So if there is a spin of atomic system, either electron, collection of electrons, nucleus, collection of electrons and nucleus in the atom, and the spin is expressed as a vector because it may rotate slightly differently, not along one axis, but differently. So when adds together everything which is spinning, multiplies it by a constant which is called Bohr magneton, and then it will give magnetic moment of the atomic system. So this is a reason why magnets, one magnetic material can be picked up by another magnetic material. So it's how the spins are connected to magnetism. So what do you see on this image? Take a break for myself and interpret the figure.
It's a sphere.
Guess what are the labels and what this sphere may refer to in respect to our meeting?
Is I just imaginary number?
Yes,
Just
yes, but what are the north and south poles? How are they labeled?
with the arrow, with the Dirac notation
And
arrows.
what is? Can you explain? Just say what you see. What are the notation? It's an arrow, and where does it point?
It points the direction of the
So
poles.
one arrow points up, another
Yeah.
is down.
Mhm.
Okay. Yeah.
U is looks like the distance from
Mhm.
this arrow to the south.
Okay, and the radius looks like 1.
Yeah.
Okay, yeah, thank you, Nate. So why, again, this is not a lecture. It is only like foreword and overview what we should get either by end of class today or by the middle class of Monday. When we get over all components of the spin math, we will need to speak about it and visualize for humans, because abstract math, even for strong mathematicians, is not natural thing. So rotation can occur in 3 dimensions. Axis of rotation can be directed in any direction. Magnetic moment of a piece of material can be magnetized in any direction. And spin and magnetism are connected. So there is a way to say where elementary magnetism of a single spin is oriented, and if length of this spin magnetization is fixed, but orientation is different, we can visualize it as a point on a sphere. And if some quantum dynamics is happening, then it will correspond to change of the position of the tip of this vector, pointing the position on a sphere. I hope Joshua will tell us more about it when he will present his project and when we will be grading his report on Friday. So this equation will, this slide will not be shown today. I objectively see that there is not enough time, but I hope very much that by the middle of the Monday lecture, we will arrive to the slide. And this slide is practical background for the project by Joshua. So the expectation values of the operators that we will introduce, like S plus and S minus, they give projections of the spin on and magnetization on X and Y axis. And if the spin, either nuclear or electronic, is placed in strong magnetic field, it starts the axis of spin rotation starts precessing, starts moving. And magnetization, if it was neither completely up, neither completely down, it starts precessing along the equatorial plane of this globe. This equation of motion for this equatorial path can be derived within knowledge that we already have in the class, and the intention is to have it done by 11:25 on Monday. The project of Joshua will and is modeling of this equatorial motion for collection, for ensemble of spins. And this equatorial motion of ensembles of spins is behind medical diagnostic procedure for MRI, magnetic resonance imaging. I'm not asking if you follow in all details, but do you see the global picture more or less? Okay. So this is Wikipedia visualization of this background processes. So there are several arrows correspond to individual spins in ensemble. Each of them act separately, but when one bring them together, they collect together, interfere constructively, and give bigger magnetic moment of the overall system. Okay, and some of this will hopefully be presented in writing on Friday by Joshua, and verbally on next Friday also by Joshua. And here are just the ways how we are going to solve these equations on Monday. Last year it was 39, this year is 41. Okay. Now it's time to start actual lecture. When we met here about 2-3 lectures ago, before hydrogen atom and before discussion of writing skills, we were speaking about 2-dimensional rotations, right? So rotations are described with angular momentum, which is just distance from center times momentum if it is 2-dimensional, and it is cross product of vectors r times p if it is 3-dimensional momentum rotation, right? Okay. So if we practice the cross product definition, it looks this way when it's to take determinant. And if you know for sure that there is rotation only in X and Y plane, the first 2 components of vector will be 0, and the last one will be non-zero. So it will be position times momentum along Y, and position along Y times momentum along X. So this gives angular momentum. Now, You all are my heroes just because you are not screaming and running out of the room and just patiently listening to it. This material and this subject is typically offered in longer and advanced courses, and it takes no less time than harmonic oscillator, so at least a month. So if you have some discomfort and you think we are going too quick, it is very natural. I'm squeezing heavily. So just try to follow general idea, and I'll tell when to wake up and focus. And if anyone online disagrees or has questions, please raise your voice. Right now, I'm looking on a screen. I will ask those who are physically here if they follow just by signs, and those who are online, I can only hear. So I hope you agree with this definition of LZ projection of angular momentum. Please confirm. Okay, thank you. And if you look for other projections, Y and Z, it will be different combinations. For Y, it is X and Z. For X, it is Y and Z. So if we try to explore commutation relations, same as we did for position and momentum, if you carefully do exploration of what happens if you apply this combination of differential operators to a wave function that depends on 3 components. And here there are 2 lectures to prove it. One would see a very interesting observation. So that if one applies rotation or angular momentum along X and Y, and then Y and X to a wave function, it is equivalent to rotation in Z projection. So if you ever had 3-dimensional modeling, either for molecular modeling or engineering modeling, you notice that one can rotate an object not by pulling 1 degree of freedom, but by making you try to rotate in along 2 axes, and it automatically rotates around another one. So if you had 3-dimensional modeling experience, you saw this effect. So this is called co-mutation relations for angular momentum. So momentum along X and Y do not commute. The commutation gives LZ. And this property is cycle-wise. If one puts here Z, X, and Y, it will be still correct notation. So they are cycle-wise connected to each other. So rotation around 2 selected axes result in rotation around the 3rd axis. And this still can be proved by our standard calculus approach, just by taking derivative to a function that we can either keep here or remove from here. Okay. Now, I'm slowly going to concept of spin. So when we had rotations and angular momentum, there were several eigenstates. And if we have true 3-dimensional rotations, it is parameterized by azimuthal angle phi and transversal angle theta. And eigenstates are arranged in increasing number of degeneracy, right? So increasing total angular momentum and then changing different values of magnetic quantum number, which is rotation azimuthal plane. The spin is an imaginary concept which allows only 2 types of rotation, 2 speeds and 2 directions. So instead of this infinite number of rotations, there will be only 2. Let's say forward and backwards. And the value of angular momentum will be not integer, not like 1 in terms of Planck constant, but fractional. It will be 1/2. So it rotates twice as slower compared to slowest orbital motion of hydrogen atom. So it will be plus 1/2 and minus 1/2. But distance between two different points in angular momentum will still be 1. Okay, yeah, sphere rotates forwards and backwards. The math to describe these two types of rotations, permitted rotations, if it rotates one direction, one can call it alpha or spin up, because spin is direction of angular momentum. If it rotates opposite, it's spin down or beta. And then one can represent it either by up and down vectors with coefficients alpha and beta, or one can use it as a vector, C sub alpha, C sub beta. Same as we did in other things, discrete quantum mechanics. And then basis functions for alpha and beta can be this vectors with two components, 1, 0, 0, 1. I need confirmation. Okay. And some people use slightly different notations. Instead of alpha and beta, they use 0 or 1, plus or minus, arrow up or arrow down. It is the thing that Nate was identifying on a sphere. Right? So we do have basis states. We do have wave functions. We can select any wave function by manipulating expansion coefficients in front of these coefficients, right? Now, we need to work out the concept of multiplying vectors and setting up operators for bra times cat and cat times bra. Make sense? So since it is counterintuitive, I'll show some fun demonstration. So suppose we have two quantum states, spin up, spin down, or just to be completely at the level of much below your level, at the level of kindergarten. We have two states of a human who has a mood to go to sleep late, a night owl, or a human who, or a state of the same human who has a mood to wake up earlier, skylark. So a coffee, a wizard, can convert the night owl by hocus pocus into skylark. Good enough as an educational tool. So quantum mechanics for everyone. Now let's apply Dirac notation to this little picture. So the night owl and skylark are quantum states. Like wizard or cup of coffee is an operator that converts one state into another. Make sense? So what is my goal for next 3 minutes? Is to express the operator in terms of Dirac notation as well. Do you accept this formulation? Okay. So if we compare night owl to night owl in the Brian cat forms, they should convolute and give 1, right? If you convolute skylark to skylark, they convolute and give 1, right? Now, if we compare state of night owl and skylark, they different. The convolution gives 0, right? And if you flip and convert, compare skylark to night owl, it's also 0. Now, if we make a construction of cat times bra, it will be an operator. So it will act on the cat vector. But if it is the same vector, if it is it will convert it to itself. If it is scalar, it will just annihilate it. There will be nothing. This cat times bra will convert the night all into skylark, right? So basically we can replace the wizard by this symbolic notation. And if we refocus on the last three symbols, they convolute into as a scalar product into one, and then we have only the leftmost symbol of the skylark. So basically, from now on, you know spin algebra. We just need to use a little more scientific notations to it. So the alpha state is converted by raising operator and gives alpha state itself. So S plus. Make sense? It converts alpha to beta, raising operator. If we set up different order of symbols, it will be lowering operator. And if you want to convert these operators into the form of matrices, we can check that if our alpha state is 1, 0, there is only one matrix that will convert it into 0, 1. It will be a matrix that will have 3 zeros and 1, 1. So by row by column here it gives 0, row by column in here will give 1. Accept? And if you place 1 in the different corner of the matrix, it will be opposite. So it will be two pairs of operators, lowering and raising. They, by math, by algebra, they are quite similar to the raising and lowering operators in harmonic oscillator. And it was one of the reasons to spend time on raising and lowering operators in harmonic oscillator to prepare foundation for this analogy. Okay. So another little mathematical exercise. If one multiplies raising and lowering in one direction, if one just follows this matrix multiplication, the number 1 will be on main diagonal at the first place. If you swap the order, the 1, like row by column, will be at the end of the main diagonal. If we add together these two operators, it will give identity operator, right? You see it. The matrix that has 1 on the main diagonal and another one on another main diagonal, if you add together, it will be all ones on the main diagonal. So their summation gives identity operator. But if we put energy of state alpha in front of first combination, energy of state beta in front of second combination, it instead of the identity operator, it will be a matrix with energies of state alpha and state beta on main diagonal, which is an energy operator, right? So from this point of view, we can define the Hamiltonian operator, total energy operator of the non-interacting spin as energy state alpha raising lowering plus energy state beta lowering raising. Also, it is an analogy to harmonic oscillator where was A dagger A plus 1 plus 1/2, right? Okay, it's about time to finish. So if you summarize this thing into a dictionary, it will be something that we can use on Monday to go forward and complete the spin chapter of our class. So thank you for your patience. Hope it was not very I know it is much more boring than doing demonstrations, but hope it will be foundation for maybe your next classes and a little bit of fun. So hope to see you tonight at 5 to finish the projects and have a nice rest of the day. I'll stay here and answer questions if any, if there will be questions from online.
Awesome, cool.
Okay.
For my project, so if I'm just trying to change the amount of pulses, what would you recommend I put n tau at? Should I keep n tau static constant?
No. You can maybe use only, let's say, 2 pulses, but change n tau, change duration, change time delay between them.
Like Rabbi, is it Rabbi the same? Those. are those
Yes,
two variables?
yes. I would. It would be really interesting to keep Rabbi the same, like 2,
Yeah.
but change the duration and see how the outcome depends on it.
Okay.
And it is something that one can do on the real experiment. The delay between pulses, you like it. Sybil, I will be with you in like 30 seconds. I'll answer to Nate very quickly. So there is a fixed speed of light. Right? So you buy or build the laser that gives short pulses, and then one puts beam splitters, half transparent glass. Oh, you are here! Excellent, excellent.
That's why I was like, I don't know, because my office is
Okay, yeah.
I work nearby, so.
Oh, that's great. That's great. So half transparent, and then for 50% it comes through. For 50% it just mirrors deflects, and then one can put a set of like 2 other mirrors that will make it 90-degree turn once, 90-degree once, and then the third one, so that this both pulses will arrive to the same sample. By changing distance to this set of mirrors, one increases time it used for the second pulse to travel, and it is just mechanically putting this distance to a mirror. So it's maybe not as simple as just pushing. Maybe one has a little screw to be precise, but it is quite simple experimental technique. So time delay means just changing the shoulder of interferometer.
Okay, that makes sense. Okay, I'll run the test before the lab today.
Okay, yeah, that's great.
I was just like, I'll just go with this.
Okay.
Are you busy or?
Okay.
We are busy or something.
If there is a next class, they may kick us out of here. Hello, how are you?
Not too bad. How are you doing?
Very good, very good. Looking forward to the end of semester.
Yeah, me too. Definitely looking